Now we've got one more kind of power that we want to look at, and that will be the complex power. So recall that the average power is equal to the RMS voltage times the RMS current times this cosine of theta minus phi. And we're going to express this in complex terms. And that's just going to be equal to the real part of the RMS voltage times the RMS current times this e to the j theta minus phi. And this term here is what we are going to call the letter S, that will represent the complex power. Or we can say that the average power is simply the real part of the complex power. Now many times you won't see the complex power written as this, you'll see it written as P plus JQ. Now this letter P here represents the average power, and you can see that we dropped off the subscript AV, and this is just common notation. And Q is the reactive power, which is the imaginary term of S, which is also equal to the RMS voltage times the RMS current times the sine of theta minus phi. And the unit for the reactive power is the volt amp reactive, or sometimes just called the VAR. And this reactive power is used for our inductors and our capacitors. So now we can look at all the different kinds of power that we have. So from all of these, we can also construct something called a power triangle, where if we have the real axis and then the imaginary axis, we have some complex power S. You can just represent it as P and Q, where this angle between S and the real axis is simply equal to theta minus phi, or that phase difference.